So it's nothing but your minus 2 by n. Okay, so it's minus 2 by n. So minus 2 by n star y minus m current y minus m current star x plus b underscore. Right, so this is what is the gradient respective. So this is very similar to, this is exactly the same as whatever we had discussed, right? So it's y minus right. So now I think it should be correct. You have your brackets. Okay, now it's fine. So now you basically write the m gradient. So in m gradient, basically what happens is minus 2 by n. Again, it's actually the same thing. Minus 2 by n star x star of. It's actually the same thing, minus current value of x plus b current. It's nothing but y minus mx plus b, right? So you get this value. Now basically what happens, you basically need to figure out what is your next step, right? So this is where it helps you. So after you've looped over your entire data set, see, after this loop is over only, you will basically enter your next step, right? So basically after you calculate your gradient for your entire data set, so after you calculate your gradient for your entire data set, after you calculate that only, then you'll basically enter your next thing. So it's nothing but b current, it's nothing but the current value of b. So this is where you multiply your learning rate, right? You just multiply with the learning rate star whatever b value of gradient is. This is generally called as the update step. This is where you basically update your weights, right? This is where basically you update your weights. So after your update are done, you basically return. Okay, you return your new weights. Right? So this is what happens in one iteration. Okay, so basically just to give a brief recap, right? So suppose you have a data set with maybe around 1 million examples, right? 1 million rows. So suppose you have a data set of around 1 million rows. Okay, and you're basically trying to figure out, it's basically trying to fit a linear regression line to that particular data set. Okay, so what basically happens in this particular case is you'll basically run this. This is for one iteration. So in one iteration, basically what happens is you'll be looping through each point. So in one iteration, you'll basically run 1 million calculations, 1 million calculations of gradient. That also depends on, say, in this particular case, I had only 2 weights, right? I had only 2 values of weights. That's why. So it's 1 million into 2, right? So it's nothing but 1 million star 2. Say suppose you have around 100 weights. You'll basically be running 100 million calculations. This is only for one iteration. Okay. So generally, it generally takes a good amount of iterations for this algorithm to converge before to reach stopping condition. So in this particular case, what is the stopping condition is? So in this particular, the stopping condition, it's basically whenever, say, whatever the new update, right? If the new update is similar to its previous position, right? If the new value of b and the new value of m are very similar to its previous thing. So obviously there is a threshold. You basically put a threshold of some certain value. So if the difference between these two is within those threshold value, it basically means this particular algorithm is converged. Okay, and whatever values you get is sort of the best values. So whatever values of b naught and beta naught and beta 1 you get are the sort of the best possible values, right? So that is your stoppage condition over here. So this is what the amount of calculation which happens in one iteration. Suppose you take around 100 iterations, right? Okay, just for simplicity, if you take even 10 iterations, right? So you're basically looking at around 20 million calculations, right? So this is what is actually happens. So this what is actually happens. I will just complete this whole process. So this is only for one iterations, right? Now suppose you want to run this for multiple iterations. You want to run this until convergence. Right. So we basically run this gradient descent. Right. So this is nothing but your data set. This is your starting A. This is your starting A, and this is your starting B. So okay, it's nothing but your starting values of B and starting values of M. Okay, so you have your starting values of B and you have starting values of M. So you have a learning underscore rate, right? So then you have your number of iterations. Yeah, in this particular case, I have fixed number of iterations, but it's generally sort of you keep on you have a check your function which basically checks the number of iterations it needs to run. So basically, after every iteration, it basically checks if this particular condition is satisfied or not satisfied. So yeah, so it keeps on running. Okay, so this is the value of B. This is the value of starting B. This is the value of starting M. Now you just put it in a loop and you keep running this for I in range of num underscore. You keep on running this. Basically, what happens is, so you'll get the value of B, you'll get the value of M. You'll basically run this step gradient. Right, you'll basically run this step gradient function. Right, so BM array of points. Right. Then you have your learning rate. Yeah, this is what is. So this is what actually happens in gradient descent, right? So in gradient descent, so what is the whole idea is, you basically need to calculate the minimum of a function. Okay, so how do you basically calculate the minimum of a function? Is one, you just don't randomly pick a value and say this is the best value. So you basically try to find out the gradient of the function. In this particular case, you'll calculate the gradient of your cost function, and depending on the value of your gradient, right? So basically, gradient is nothing but your slope, right? Slope at a particular point. So if your slope is positive, it basically means you should basically nudge the function in the opposite direction, right? The slope is increasing basically means at this particular point, if you actually if you actually go in the direction of the function, right? If you actually go in the direction of gradient, your value increases. But this is not what we want, right? We actually want to go in the opposite direction because we want to go to the minima, right? So that's where your gradient helps. Your gradient basically helps you in the direction. And because from any particular point, you can have n number of directions. You can go in n number of directions, right? So that's why you just basically go in the direction opposite to the gradient. And in order to know what is the magnitude of the next step you need to take, right? Again, it's the same analogy. So you're at the top of a hill. You're at any position of a hill, and you basically need to figure out what should be a next step. Right, so your gradient descent will tell you how much. It will tell you the magnitude as well. The magnitude is basically what is happening in this step. You basically loop over your entire data set and you aggregate the value in B gradient and M gradient. Then you basically multiply your gradient with the learning rate, right? And whatever value you get, that is basically your next step. Okay. So the reason for using learning rate is this: if you don't use the learning rate, right, there's always a good chance that you'll take larger steps. And in taking larger steps, there's always a good chance that you'll overshoot the minimum. Right? Since this is an iterative process, right? Since gradient descent is an iterative process, if you actually overshoot the minima, you'll again go into this continuous loop where this process keeps on going. So you won't be reaching your minimal point, or you won't reach your convergence. That is the idea of using multiplying your learning rate. And in the next session, we'll basically have one example where we actually use the same code on an actual data set and try to understand or get a bit more clarity on this process. Yes, thank you.